Good morning, Anatomy and Physiology. This is Mr. McGee. I'm going to give you a video tutorial today on how to do your assignment and make a presentable table and a graph on Google Sheets. You're going to be doing this with your substitute, and I will not be there to physically help you, but make sure you're watching this video tutorial and going back if you need extra help with it. This is not due at the end of class today. It is actually due the next time I see you, so either Tuesday or Wednesday, and make sure you submit this on Google Classroom. So ultimately you're going to be taking this and pasting it on this Google Doc because this is your actual assignment. Paste your table and graph once you have made it right there just like that. So follow the directions clearly, and the reason we're doing this is number one, we want to analyze enzyme results because I want you to learn about enzymes and how they deal with our body. But the other reason is because as a scientist, it's important to learn how to graph and analyze data, and computers make this job very easy when you get to use a computer for all of this. So part of our objective today is to not only teach you enzymes, but also how do you use a computer to process this data. I still use computers in my everyday life. For example, when I want to graph out my bills, or if I want to graph out the heat usage over each month of the year, like how much electricity I'm using. I want you to learn this. So please make sure you focus on it, and hopefully you'll have fun with it. So let's go ahead and begin. I have given you a table here with a nice heading. This is just so you can come in and see exactly what there is. And again, you can see class averages. I took your entire class and I averaged your data that you gave me, or I took a picture of while you were in class. Let's go ahead and separate this from the other stuff. So I'm going to highlight that, go up here to fill color, and let's add a nice little background to that. That way it's got a little shade and it's a little separate. Down here, let's go ahead and highlight these cells and give them a nice little border to distinguish them from the background. Except I don't really like that border, that's too thick. So let's go back under border here and go to make it a smaller line. Now that we have that, I do want to add a thick border in one particular place. This is our independent variable. This entire area is our dependent variable, if you remember that concept. I want to separate the borders right there. So in order to do that, I'm going to highlight our independent variable, the time of the reaction, and I'm going to go back to border, but I'm going to select this little line over here like this. And then I'm going to go now and tell the computer, let's make it a thick line on that border. And there you go. Our table looks really nice and it has that line separating it. Next thing you're going to want to do is calculate your mean, and you can do this by hand, or you can click on the cell that you want to calculate, go up here to functions and go to average. All you have to do is highlight the cells in that row that you want calculated and hit enter. Go ahead and do that for each row and then hit enter. Okay, click average, highlight the cells, enter, and I got one more row. And that is it. So now that we have that, it looks pretty presentable, and for most middle schools it's probably good enough, but I would like you to go a couple steps further. Number one, let's make this a little more presentable by centering it. So we'll just highlight the raw data and go up here to horizontal align and make it centered. But another thing we want to do is notice the decimal points are really kind of off and they're kind of all over the place. I would like you to do this. With your raw data that we collected, that is averaged, notice some of them are whole numbers, some of them go up to 2 decimal points of precision. Our instruments were only capable of 1/10 of a milliliter, so I don't know why some groups did this. We should have been on the same page, but that's the data you gave me. So to standardize this, we go up here to data or decimal points. You could round it to a whole number, but we don't want to do that. We could add a bunch of digits, but we don't want to do that. We want 1 decimal point of precision for all your data. And a good rule of thumb is your processed data from all that raw data should have 1 extra decimal point than your raw data had. So if these all have 1 decimal point, your processed data should have 2 decimal points. With that said, I think our table looks very nice and presentable, and make sure you take the time to look at it and understand what it's trying to tell you. So at this time, I'm going to go ahead and click and highlight our table. I'm going to go up here to control and copy it, and I'm going to open our Google Sheets assignment, and I'm going to go here and under table, and I'm going to paste it. And you can just paste it on linked. So now that we have our table, let's go ahead and make our graph. Now to do the graph, you need to tell the computer exactly what is the X and the Y axis. There's several ways to do this. The easiest way is just to do this. Click on your raw data for your independent variable. And so do not highlight the title, just the raw data. Now you got to click and hold Control on your keyboard and hold and then highlight your mean. This is your x-axis, this is your y-axis. So again, once you do that, go up here to Insert and you hit Chart, and for all purposes it looks like a legitimate chart. Except we don't want a bar graph. We want a scatter plot. So go up here under Data and click Scatter Plot. And now what you're going to want to do is adjust a few things. So we go under this tab which is called Customize, and we can do all sorts of things to get this to be different. First thing I'm going to want to do is, I'm not a big fan of those grid lines unless you're using graphing paper. So I'm going to go ahead and go under grid lines, and under vertical axis I'm just going to tell it I don't want a color. And under horizontal axis I'm just going to tell it I don't want a color either. Just looks a little nicer. Next thing, let's go ahead and look at our scaling of our axis. 0 to 400, well, there is no 500. Yet on our table it should go 0 to at least overshoot it to 500, so we need to fix that. You could just go here to horizontal axis and title it, or you could just double click on the axis and it'll open it for you. Tell the computer you want a minimum value of 0 and a maximum of 500. And that is it. It scaled it. The y-axis, it is pretty scaled. 0 to 4 should be pretty sufficient. Except we really don't need those 2 decimal places there. It's just kind of a waste of space. So again, you could double click on this and it'll open the vertical horizon. Double click on it. Or you could just go here under vertical axis and open this up. Now we do not need to set a minimum and maximum, it's already there, but we do need to tell it the format, and in this case, custom. So what we're going to do with custom is nothing. If you wanted to make the numbers in the millions, you could add 6 zeros and it will change those to millions. You could add a decimal point and it'll add 2 decimal points as a suffix. We don't want anything, so you just go to custom and leave everything blank. And that is pretty much it when it comes to the scaling. Next thing we need is to make sure we have a nice title and y-axis and x-axis titles. So this is not a very descriptive title. A better title would be I just threw this in there, but you can change your title up if you want to. That's more descriptive than the one it had. Now let's look at our x-axis, the time of the enzyme catalyzed reaction, and it has a unit in seconds. You always want units. That looks like it matches. This y-axis, here's the tricky part. The computer took a guess and guessed it was the mean, but mean doesn't really tell us anything. Mean of what? And in this case, we want to adjust it a little differently. I'm going to go under here under chart and axis titles and change the text to the mean amount of uncatalyzed hydrogen peroxide substrate. And then you want your unit, of course, in milliliters. You don't want to leave that out there, obviously. So that's a more descriptive title, the mean or average amount of uncatalyzed hydrogen peroxide substrate. But notice it's kind of cut off there a little bit, so we're probably going to want to scale this up a little bit to make it fit, or you can adjust the font by basically double clicking and going here under font size, but obviously that's something you can play with. Your computer may look a little different. The next thing we want to do is probably make it a little bit bigger. I don't really need this mean here. You guys can actually get rid of that, and you can just go under legend, as you see. I don't really need a legend, so instead of telling it the position, I'm just going to tell it I don't even want a legend. So that doesn't hurt it. I just like to use the most space on my graph. But there is one more thing that you and I need to do, and that, or I guess you need to do, you need to make a line of best fit. And in this case, a tread line. Go to Series, go down here to Tread Line, and under Tread Line, you want a line that's going to fit the data points the best. In this case, linear seems to fit, exponential does not, polynomial fits pretty good too. You can pick whatever line you want that fits your data the best, and the computer is trying to process an equation to make that fit. And I will let you pick if you want to change this to a different color, or you want to, make it some bizarre color or something. That's completely up to you, but make sure you have a tread line of best fit. Now that we have that, let's go ahead and copy our graph. You want to click somewhere on the graph where the whole graph is highlighted, and then you want to go up here to Edit, Copy, and then go to your assignment, and under Graph, click Edit and Paste. And you can just paste it unlinked. If you want to adjust the size, you can do that. That's probably too small, but notice I'm adjusting the size to make best use of space. Heck, you can even click on it, and you can even make it centered like that if you want to do that. So the next thing we want to do, even though you've made your graph, I can clear it just so you can see better, but now that we've made our graph and we've pasted our table and graph, we want one other thing, and that is our square. Our square is very important in science because it tells us how good our data is at forecasting. And our square that is closer to 1, which, by the way, getting exactly a 1 is almost impossible, but if every data point fell right in the middle of a line, that would be an R square of 1. If the data points were random and there was no order to your data, it would be an R of 0. Generally in science, we want an R square of 0.7 or higher, and that is considered a strong trend. Weather predictions, by the way, are usually no better than about 0.5 in their R square. And for that reason, we can predict weather forecast short term, but predicting it long term is a little hard because the data, when we take weather pattern data, is really kind of out there. We want to look at our graph, and I probably shouldn't have deleted that just so you can see what's happening here, but does that look like a very good predictability? I think it is, but we want data. Click on an empty cell anywhere you want to and type exactly this to calculate your R square. The instructions are on your Google Sheets, but you calculate equals RSQ and then the left parenthesis. That's it. Equals RSQ left parenthesis, and then you do this. Highlight your raw data for the independent variable. Click and hold Control, and now highlight your mean in a dependent variable. Once you do that, hit Enter, and that is R square. R square is equal to 0.9995594. Yeah, I would say our R square is very high and close to 1. This means our data has a high predictability. I will let you answer these questions, but how confident are you of your prediction? Think about R square. And I would like you to make a forecast. 700 seconds and 1,000 seconds. Where do you think our hydrogen peroxide substrate levels would be at that time? Use your R square to calculate that. With that said, make sure everything is complete on your lab sheet here. This is really the only thing you're turning in. And again, we're going to do this on Google Classroom. I obviously don't have it posted because I'm making this video, but you're going to get everything off of Google Classroom here on the assignment. Make sure you posted it. You can always email me, but it is your responsibility to make sure you get this done. If you cannot, for whatever reason, post it, you are responsible for printing this document and somehow getting it to me when we see each other next. So with that said, I hope you all have a wonderful weekend. I will see you later.